Substitution here, and I'm going to call v equal to xy. We started with dy equals x. I'm going to substitute v equal to xy instead. So if I take the differential of both sides, I get dv dx, derivative with respect to x, is equal to 1 minus dy dx. And then I can switch this around and write it as dy dx equals 1 minus dv dx. So I know dv dx, 1 minus dv dx equals dy dx. So I come over here, I stick 1 minus dv dx in for dy dx. It's equal to x minus y, which is equal to v. That's just the substitution that I had over here. And now I've got that. Now I can separate my variables. So I bring the 1 over, that becomes 1 minus, subtract 1, divide by negative 1, makes it 1 minus v is equal to dv dx. And I can multiply this side by dx and divide by 1 minus v, so I get dv over 1 minus v is equal to dx. Now my variables are separated. I can go ahead and integrate. So I got the integral of 1 over 1 minus v dv. That gives me ln of 1 minus v is equal to the integral, and that gives me x plus c. I integrated. And notice I have a u prime, which is that negative out here. So I bring that over here and divide. That gives me negative x minus c, which is really just another c, so that's just plus c. And that's part of that constant magic that we talked about, constant magic. And then I go ahead and take e of both sides, giving me 1 minus v is equal to e to the negative x plus c. Multiplying things the same base, we add the exponents. So this is really e to the negative x times e to the c. And e to the c, this is the really cool constant magic. It's just some other constant, so boom, it's another c. Now I could have put c1 there, but I didn't. It's just c, another ni. So I have 1 minus v equals c e to the negative x. And now I substitute x minus y back in for v, and I solve for y. So I go ahead and bring add x to both sides and subtract 1. That gives me 1 minus c e to the negative x plus x minus 1. Now solve for c at the point 0, 1. This is that Euler's method where we started at the point 0, 1. So I stick that in there and I find out c is equal to 2. So now I've got my equation. This is my equation for y that we were looking for. And now I can use that to evaluate it at 0.5. So I come over here and I evaluate it at 0.5, stick 0.5 into it, and I get 0.71306. So calculated x at 0.5, I get the y value is 0.71306. Notice with Euler's method we got 0.681. This is an approximation. This is an exact answer. Very cool. Managed to do it. Have a great weekend. Just make sure you watch this video.